You have been tweaking your chunk size, adjusting your prompt, and swapping retrieval strategies. But how do you actually know if things are getting better? Without measurement, you are just guessing. RAGAS is an evaluation framework that gives you 4 concrete scores for your RAG system. In this episode, we set it up, run a full evaluation, and learn how to read the results. Manual testing does not scale. You can check 5 questions by hand, but a change that improves those 5 might quietly break 50 others. Automated evaluation runs hundreds of questions and produces consistent comparable scores. More importantly, RAGAS breaks performance down into separate metrics for retrieval and generation. This means you can pinpoint whether a drop in quality is caused by the wrong chunks being retrieved or by the language model misusing the context it was given. RAGAS provides 4 metrics that together cover the full RAG pipeline. Faithfulness measures whether every claim in the answer can be traced back to the retrieved context. Answer relevancy measures whether the answer actually addresses what was asked. Context precision measures whether the most relevant chunks are ranked at the top of the retrieved list. Context recall measures whether all the chunks needed to construct a complete answer were actually retrieved. RAGAS expects a dataset with 4 columns. Question is the original user query. Answer is what your RAG system returned. Context is a list of the chunks that were retrieved for that question. And ground truth is the correct reference answer you wrote by hand. You build this dataset by running your RAG system on a set of test questions, collecting the outputs, and pairing them with reference answers. Even 50 well-chosen questions gives you meaningful scores. Running faithfulness takes around 10 lines. We wrap our language model and embedding model in RAGAS-compatible wrappers. Then, call evaluate passing the dataset, the metric, and both models. RAGAS uses the language model internally to check whether each statement in the answer is supported by the retrieved context. A score of 0.91 means 91% of answer claims are grounded in the context. Below 0.7 is a serious hallucination problem. We add answer relevancy and context precision to the same evaluate call. Answer relevancy checks whether the answer addresses the question by generating multiple questions from the answer and measuring how closely they match the original. Context precision checks whether the most useful chunks are ranked at the top. A context precision of 0.73 tells us our retriever is finding relevant content, but not surfacing it near the top of the list, which is a signal to improve ranking. Context recall requires the ground truth column because it measures how much of the reference answer is supported by the retrieved chunks. A score of 0.68 means 32% of the information needed to answer correctly was never retrieved at all. This is a retrieval gap. The fix is to increase K, improve your chunking strategy, or add hybrid search from episode 6. Low recall is not a prompt problem. It is a retrieval problem. You can run all 4 metrics in one evaluate call. Calling to pandas on the result gives you a data frame with 1 row per question and 1 column per metric. This makes it easy to spot which questions scored poorly and trace back exactly what went wrong for each one. Run this before and after every change to your pipeline so you have a concrete before and after comparison rather than a subjective impression. Here is a quick reference for reading your scores. Faithfulness below 0.7 means the model is hallucinating and the prompt needs stronger constraints. Answer relevancy below 0.8 means the answers are drifting off topic. Context precision below 0.7 means ranking is poor and you should add re-ranking. Context recall below 0.7 means chunks are being missed entirely, and you need better retrieval coverage. When all 4 scores sit above 0.85, your system is in solid shape for production. You now know the 4 RAGAS metrics, what each one measures, how to run a full evaluation, and how to use the scores to diagnose exactly which part of your pipeline needs work. In the next episode, we go deeper into hallucination detection, how to catch cases where the model confidently states something that is not in the context, and how to handle them gracefully in production. Subscribe so you do not miss it. See you in the next one.